So we got through a lot of 5-4, but we didn't finish 5-4 the other day. So I just kind of wanted to talk through what does real world SOHCAHTOA really look like. So if we're looking at a fire truck and it has a ladder that could be extended to 108 feet. Do you guys agree that a ladder to the top, typically every floor of a building is about 10 feet tall? So if a ladder is 108 feet long, how many floors could it probably get to? 10, 11 floors, right? Would we need the ladder fully extended to get to the top of this building, which is 2 stories high? No, right? But it could be up to 108 feet when it's extended. Okay. An expert for the department indicates the optimum operating angle of a ladder is 60 degrees. Meaning, if you put a ladder like this, is that going to be hard for the fireman or woman to potentially climb? I would say so. What if you put the ladder like this? You're going to be like crawling, like bear crawling. You know what I mean? Like that's going to take you a while. But they're saying 60 degrees is a good height I would say 60 degrees is a good height to for the safety of the fire person as well as the efficiency and practicality of getting to where they need to go the fastest. Okay, so they're reaching the top of an 84-foot building. 84 feet building. Oh, the ladder is mounted 8 feet above the ground. So I feel like I should have put the ladder on top of my red fire truck. Red fire truck with big lights and sirens. Woo, woo, woo. You guys, the truck is mounted 8 feet up. The ladder is mounted 8 feet up. And it says, Then the optimal angle is 60 degrees. That's how I would draw this picture. And it says, how far from the building should the base of the ladder be placed to achieve that optimum angle? So do you think that we are looking for A, B, or C? A, right? How far from the base, right? So we're going to be looking for A. So I'm going to go ahead and move that B and C. I'm actually going to label it X. Let's go with X. We're looking for X. How kind of SOHCAHTOA could I do in order to find that X? Tangent. You're saying tangent. And if I need tangent, what would I use for that opposite side, Hen? 76. Nice. How'd you get 76? Yeah, he's like, well, I'm already 8 feet up. So 84 minus that 8 is going to get me 76 feet right there. Love it. So he says TOA. Let's go find the tangent of 60 is the opposite over the adjacent. We would multiply by that denominator. And we would take 76 and divide it by the tangent of 60. 76 divided by the tangent of 60. $43.9 feet. Did anyone get that? Okay, you guys, then when it says how far, so we got that one. I did all that work right here. Oopsies, that goes right here. Boop. How far should the ladder be extended to reach that roof? Now I'm looking for that hypotenuse on that triangle. I'm looking for that hypotenuse that I'm going to call Y. What would that hypotenuse be? SOHCAH or TOA? Anyone? Sine. Thanks, Henry. The sine is 60. It's going to be the opposite, which was 76, over the hypotenuse, which was Y. And maybe some people just jump to knowing if we're multiplying by that denominator, it's always just the same as 76 divided by the sine of 60. We can type that in our calculator. What are we getting for how long that ladder should be extended? What'd you get, Thompson? 87.88? 87.8, 87.75. Perfect. Thanks, bud. Let's go scooch on over to page 22, if you would. And when you're in an airplane, who likes it when they're like, oh, now we're descending to get to the airport, and they drop really quickly? I don't like that. I don't like that one bit. And then I'm going to vomit, right? This airplane is saying we're only descending at a 6-degree angle of depression. I dig that. 6 degrees is pretty reasonable if you ask me, okay? Here's what I need you to take from this, though, you guys. An angle of depression will never, ever, ever, ever be this. An angle of depression will never, ever be that one. An angle of depression has to start at a horizontal and go down. What will it always match? The angle of elevation. They'll always be the same. So if I tell you the angle of depression was 6 degrees, you could always just put a 6 degree right there. They're always going to match. Does anyone remember for a Hershey Kiss or mini candy cane, what kind of angles those would be? They are cute. Let's go more specific. They're equal because they're sorry. Angles.
Alternate interior.
That's it. Alternate interior. I'll give it for opposite. So, okay, peeps. It says, what's the plane's ground distance to the airport? The plane is only 3,900 feet up. That's not too high. What's the plane's ground distance? So we're looking for this. I'm going to go ahead and name that X. SoCa or TOA based on this red triangle. TOA. I'm down with that, Thompson. The tangent of 6 equals the what over the what? The opposite over the adjacent. So I know what X is, excuse me, tangent 3,900 divided by the tangent of 6. What are we getting for that ground distance? 37,106 feet. Does that make sense if I'm only going down 6 degrees? That it's going to take me quite a while to land at that. And I'm good as the passenger of that airplane. 37,000 feet sounds like a great amount of horizontal distance to cover. How far must the plane fly to reach the runway? Well, we already know its altitude and the ground distance. Isn't this the path of the airplane? So let's go find that. Let's go call that guy Y. And what would Y be? SoCa or TOA? Again, we're going off of the 6 degree angle. So sine of 6 is the opposite over the hypotenuse. So then we got 3,900 divided by the sine of 6. What did you get for that? 37,310. Does it kind of surprise you that that's not that much longer than the ground distance? It is longer because of the hypotenuse, but again, it's because this angle is so little. Because that angle is so little, these might be pretty similar, and that's fine. Last one I want to do is just talking about 2 people flying kites. Latasha has reached a released 250 feet, wow, of the string of her kite. Here's my kite. Woo! Here's my kite. It's going to be pink. Boop, 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 boop. There's my kite. And I'm going to say that was Latasha's kite. She's let out 250 feet of string. And it says Latasha's kite string makes the angle the string makes with the horizontal is 35 degrees. Boom, I've got a right triangle. We've got to do something pretty similar for my girl, Markeisha. Her kite, she's only let out 225 feet of string. The angle that she has made is a 42 degree angle. Which kite is higher and by how much? I just want a prediction. Anyone have a prediction? Why?
Because the angle's bigger.
The angle's bigger, even though this side isn't as long?
It's like there's more difference between the 2 angles than there is between the 2.
Interesting perspective. I like it. I dig it. Let's go do it. How would we go ahead and find, I'm going to call that X and that Y. SoCa or TOA? Sine, he's saying the sine of 35 is the opposite over the hypotenuse. Sine of 42 is the opposite over the hypotenuse. So we have, what did you get for each of them? So I got 143.4 feet for Latasha versus Markeisha at 225 times the sine of 42, 150.6. How much taller is Marquisha's?
7.2.
Yeah, I'm just going to take that original and subtract. Bless you. 7.2 feet higher. Bless you. With the remaining 24 minutes, let's just do pages 23 and 24. And you might be like, what is a reference angle? So I'm going to show you. Here's the key for the first page. I think that you'll be better suited for the second page. Here's the key to help jog your memory for page 20. What page is it? 23. So we're going to do pages 23 and 24 today. Here's the key to 23.